So here we're looking at the relationship between airfare in dollars, it looks like, and distance to the destination from Atlanta. And we'll just review some topics. Dylan, could you describe this association, please, between airfare and distance?
Positive, linear, moderate and strong.
Yes. Any outliers or unusual features?
What's the one that's the farthest distance? That one's kind of.
This one, a bit, can be pointed out, certainly. There's nothing wrong with pointing it out. As well as these here.
Yeah, there's nothing.
This one here, I might also point out. This city, whatever it is, can somebody find the cheapest city, please?
The cheapest one?
Yeah. Kansas City, okay. So for whatever reason, Kansas City is much cheaper than we would expect given how far it is away from Atlanta. So this point here is going to have a high residual in absolute value, and those could also be considered outliers. Along with this point here. This point here, that's around 300 and is like 800 miles away. Maybe Oklahoma City. Yeah, I think so. So it looks like Oklahoma City is unusually expensive given how far it is away from Atlanta. So those are things you can point out. But know how to describe an association by now in context. So you could say the association between airfare and distance is positive, apparently linear, moderate in strength. There's certainly a fair amount of scatter about a linear model. And there are points that could be considered outlying values, for example, the 4 points on the right portion of the graph, and also this point here that has a large negative residual, and this point here that has a fairly large positive residual. Good, that's just review though. Next, Ariel, could you tell us how to find r squared? Thank you very much. Paul, could you tell us how to find r squared?
They provide you with the correlation.
Yes.
Square of 169.
They provide you with a correlation. Capital R squared is the more general statistic because not all models are linear models. However, for the least squares regression line, capital R squared is the same thing as lowercase r squared, meaning you can just square the correlation and get what capital R squared would mean. So 0.694 squared, 0.482.
So lowercase r squared is equal to uppercase r?
Squared for the linear model, for the least squares regression line. R, little r squared equals big R squared for the LSRL. R squared is a general statistic. Describing the fraction of variance explained by a model. Or predicted. Okay. Now, maybe somebody can explain what it means in context. Chris, want to give it a shot? What does this 0.482 number mean in context?
Means that 0.482 of the actual variance is, well, in context, so the 0.482 of the variance of the fares predicted by the model.
Well done. 48.2% of the variance and fair is predicted or explained by the model. In this case, the model is the LSRL. Rotem.
So let's say if you take out the lower outlier, like the very lower,
Yes.
would that go up?
Yes. And I'm really glad that you're thinking along those lines about what outliers do to R or R squared. Just to recap what he said, if we were to remove this point, Kansas City, because it is a point with a high absolute value residual, R would go up, and thus R squared would go up, which makes sense. The lower your errors, the higher your predictability, meaning like your prediction power. R squared is used to ascertain how much prediction power a model has. One could argue that this model does not have very good prediction power because over half of the natural variance in airfares, the fact that the airfares differ from a mean, is not being explained by a model here. But one could argue it's a decent model. Now, the slope and the y-intercept of the regression line. There are formulas for this, and I assume that's what the calculator is using when it is giving you the slope and the y-intercept when you do StatCalc 4. There's a concept called regression towards the mean, which Francis Galton discovered in the 19th century that I will get to and will help in your understanding of why the slope of the regression line is what it is. For now, I will just tell you the formula. And it is on the AP formula sheet, so it's something that you don't have to memorize. But it's a pretty simple formula. It's the correlation times the standard deviation of the y variable over the standard deviation of the x variable. Like I said, a simple formula. This is why I told you do not need to enter the data into your calculator. So the correlation is 0.694. Someone please say out loud what's S sub y for this data. 56.37. It's in the table here. Airfare is your y variable. Even though they don't tell us the units, I'm going to assume that it is dollars. That helps in the interpretation. And S sub x is obviously 497.8. And I will assume that is in miles. That is the slope of the line that makes the residuals squared the smallest they can possibly be for this data set. And this is a remarkable discovery. It might seem mundane or simplistic to you, this formula, but this was a huge deal because for many years no one knew this. They had to guess or use much more advanced mathematical techniques. So 0.0786, that's how precise I'll be. And it's dollars per mile. That helps in the interpretation. You'll see several symbols for slope in the world of statistics. You'll see A sometimes, B sometimes, B sub 1 sometimes. Sorry, there's no standard. Okay. So that's why I'm not even putting an equal sign here for another symbol. I would just know that this is the slope. Next, the y-intercept. So we know now that the means are always a point on the least squares regression line. You can use that to determine the y-intercept. Yes.
But can you also just plug in the slope and then 2 points will give you a chart?
You have to know a point on the least squares regression line, though.
So like adding the data or like
Yeah.
Yeah, Allie, the data does not necessarily fall on the least squares regression line. But the means absolutely will, always. So, it's simple algebra. Slope-intercept form, y equals mx plus b. Solve for b. What is it? Y minus mx. Good. You know that y bar is a y coordinate on the line, and you know that x bar is an x coordinate on the line. And you have already calculated the slope. So that's how you find the y-intercept of the least squares regression line. Again, no standard for the symbol for y-intercept. I've seen b sub 0. That's a common one. All right, so your y mean is what? 244.33. Good. You already found your slope, 0.0786. And then the x mean is 853.7. You just use your calculator. I'll use my answer memory to be more precise. Okay, that is the y-intercept, 177.24. Units, anyone? Dollars, probably. So I and the College Board will require that you know how to find the slope and the y-intercept of a least squares regression line without data. In other words, just being given the means, the standard deviations, and the correlation coefficient. And like I said, the formulas are given to you, so it's not that difficult. Good. All right. Now we're ready to write the equation of the model because we have the slope and the y-intercept. I recommend that you write it in context. So we are predicting fair hat. And it does not matter if you write the slope component first or the y-intercept component first. 0.0786 times distance plus 177.24. Easy. If you take a statistics course in college, most likely you will do multiple regression, which is using multiple factors to predict one thing, and therefore you'll have multiple variables in your equation. Or you'll do nonlinear regression, like cubic regression or quadratic regression, and therefore you'll have multiple instances of a single predictor variable with different powers on them. Okay, so this is the simplest one possible. Good. 6 and 7 are pretty easy. You're just plugging in. So about $193 is our predicted airfare for a 200-mile flight. So 2,000 goes in for X. .0786 times 2,000 plus 177.24. So we expect it will cost about $334 for a 2,000-mile flight from Atlanta. Any questions there? Pretty simple. Next, using those estimates, draw the line on the scatter plot. So we want to plot 200, 193 and 2,000, 334. About there. And then connect those two dots. Remember, you can use your calculator's lid as a straight edge. That is the line that minimizes the sum of the squared residuals, aka the LSRL. Most commonly used method for creating linear models. Okay, since we've done problems like 9 and 10, I'll ask a random person to do their best with those. Paul, to the best of your ability, could you explain what the y-intercept means in this context?
I said it's the y-intercept is the minimum fare for a flight, like the 177.
Yeah, I would agree there. $177.24 could be considered the minimum expected fare for a flight. And I think you all know the mathematical interpretation, which is fine to include as well. You can say it's the predicted cost for a zero distance flight. Any questions on 9? And Dylan, please try to explain what the slope means.
The slope is as the distance goes up by .0786, .0786, the price is expected to go up. Is that your point?
So let's try again. This is 0.0786 to 1. So the 1 corresponds to your miles. You said 0.0786.
Every mile more, the price is expected to go up by .0786.
Very good. For each additional mile, to the destination, we expect the ticket to cost about 8 cents more. The y-intercept in this context is like how much money it costs just to get on the plane. Oh, you want to sit on this plane? It's going to cost you $177.24. But that's a prediction. Take a look. Kansas City costs less than that. And it's quite more than 0 miles away. So it's showing you that the model is not by any means perfect.
You can see like a plane where it's cheaper to go actually somewhere like Kansas, right?
Yeah, but again, it's because the model is not perfect. And then this one here, it's like, oh, you want to go an additional mile? You better fork up 8 cents, buddy. Again, it's a prediction. Number 11. Random person Rotem. Please define a residual for me. In general, how is a residual defined? I think you do. It's y minus y hat. You could have done either, but that's sufficient for this problem. So, Rotem, tell me what you think the y is in this. Mm-hmm. Very good. $212 is our actual y value, and then how do we find the predicted y value? So you already have your model. It's here, 0.0786 times the distance plus 177.24. So just use that. They tell you the distance, 1719. Yep. .0786 times 1719 plus 177.24. Our model predicts that the flight to LA will cost about $312. Okay, so it's about negative $100. We were off by $100 in the negative sense, meaning that the flight is actually cheaper. Yeah.
When do you square that?
When do you square it? When you want to find things like RMSE. It's when you want to find root mean squares, which are measures of averages. They're types of averages. Yeah. Okay, any questions on 11? So know how to find a residual. Everything on this worksheet back and front is considered essential knowledge, skills, and understandings. Okay, Paul, in general, what do you think a positive residual means?
I guess that means that the model underestimated the value of the question.
Yes. A positive residual means that the model underestimated the y value. Think about it. If it's a positive residual, that means that your actual is more than your predicted. In other words, your predicted is less than your actual. So it underestimated. And then obviously a negative residual means it overestimated. Meaning that the y hat is larger. Any questions on 12 or 13? Okay, the back. It is very common for the College Board to provide computer output regarding regression on the AP Stats exam. What they're trying to do is assess a full course in the matter of 3 hours. And our course for our textbook consists of 27 chapters. Hopefully you can appreciate that is a difficult task to assess 27 chapters worth of understanding in 3 hours. They do not want you spending time punching things into your calculator, for example. So they are, like I said, prone to give you things like this. All the calculations are done. They just want you to interpret it so they can check to see if you understand things. So I'll explain several of the items on this output. The first item is your y variable. I think you know by now that a dependent variable is generally considered a y variable. I don't know what no selector means, so obviously you don't need to at this stage. R squared, you know what that is. The proportion of variability in the y variable that is being explained or predicted by the model being used. So 48.2% of the variance in airfares is being explained by the linear model using distance as a predictor. It's a performance metric. Okay, so one could argue that it is not a great model because the R squared is not near 100%. No need to worry about R squared adjusted. That's used for multiple regression, a topic that you will probably cover in college. S, I wish they made it more specific than S. You want to take a guess as to what S is? Yes, it's a standard deviation. It's a standard deviation of the residuals, which is otherwise known as RMSE. So this is your average error.
So the S is R.
S is S sub E, which is the standard deviation of the errors, otherwise known as RMSE. Root means square error. So on average, when we're predicting the airfares from the distances using this model, we're about $42 off. At this stage, no need to worry about degrees of freedom. However, you can see how it relates to the denominator of RMSE. It's n minus 2. Next, portion, where it says source. Sum of squares, we dealt with that yesterday. The first one, I'll give myself more room here, is the sum of y hat minus y bar squared, otherwise known as SSR, sum of squares regression. It's predicted variance. The next one, you know what a residual is, so I think you can do that one. Just put a residual in the parentheses. Y minus y hat. Often shortened to SSE, sum of squares for errors. Okay? And as I said yesterday, SSR plus SSE equals SST, total sum of squares. I wouldn't worry about degrees of freedom at this stage. The means just come from dividing the sums by the degrees of freedom. Gives you a measure of just overall. F ratio, probably in a college stats course you'll cover. The next portion we'll need. So in multiple regression, you can have multiple variables, which is really cool, but we're not going to do that in this course. So for the computer output that you'll see in this course, there'll only ever be 2 lines here, a constant and then one for the predictor variable, in this case distance. So this is your x to the 0 term, and this is your x to the first power term. A coefficient of a constant is just a constant, basically. So this is the y-intercept here, because that's the constant term in a linear model. Okay, it's the yint, which is Yiddish for y-intercept. That was a joke. The next one, the coefficient of the x variable, what is it called?
Slope.
Slope. And at this stage, no need to concern yourself with the remaining columns in those rows. Okay?
You don't need to know the rest.
You don't need to know the rest at this stage.
What was the D?
Degrees of freedom. I would worry about that later. Okay? Yes?
What are the x variables raised to?
The first one is raised to the 0th power, and the second one's raised to the 1st power. You could also have nonlinear models, like a quadratic model, and that would have another coefficient. Great. And then over here you have the scatter plot and the residuals plot. Our first question is the linear model appropriate for estimating airfare from distance flown? So first I'll ask somebody to give me their thoughts. Roten.
Somewhat, but no, because our squared is pretty strong.
Okay.
And then you can also see that it's kind of off the line, but it still is a linear line somewhat. So that's helpful.
Okay, so just to reiterate, he said somewhat because the r squared is not very high. When you look at the scatter plot, it looks linear, so that would be a case for it. Let me tell you, because I've done this enough, that when they ask if the model is appropriate, that is different than is the model good. I repeat, a question of is the model appropriate is different than is the model good. A good model has a high r squared. An appropriate model is one that has no pattern in the residuals plot. And if that doesn't make sense to you, I will try to explain with a different situation. So let's say that this was your scatter plot, and you put a least squares regression line to that. Which might look like that. Think about what the residuals would look like. Some positive ones, and then it goes negative. And then back to positive again.
So then could you have a good model but not an appropriate one?
That's a great question. You could. You could have a model that has a really high r squared, but is technically not appropriate. Which means that it's not the mathematical function that is the truest one. Okay? Yes.
When you look at these two, well, that or this doesn't matter, but if you were to like turn the first one, like if you were to move the line down so that like the slope was 0%, zero, are they supposed to look exactly the same? Like they look exactly the same. If you
Yeah. No, it's supposed to be, because this is that. So it's just a rotated version. Yeah. Oftentimes the residuals plot is not surprising, but I have experienced times in which it is. For example, you could look at a scatter plot and it could look linear, and you might think, oh, I'm awesome. My r squared is 99%. And then you look at the residuals plot and there's a curve in it, and then you realize that you're not as awesome, but you still might be pretty awesome. Okay? What it means is that you could still improve. Like, for example, this thing probably has a high r squared, maybe like 90%. That would normally be considered a good model. However, we could do better. Why do I know that? Because when I look at the residuals, it's not scattered evenly about the line. Okay, there's some pattern that's there. So in conclusion, I'll say one could consider this appropriate. Because there is no pattern in the residuals. You do not want a pattern in the residuals. No, you want scatter, randomness.
Would you say that the other one was a pattern that you drew because it was positive and negative was positive?
Yes. And the scatter plot looks linear. But you really don't even need to say that last part, because if it didn't, then you would see something in the residuals. Okay. So when somebody asks you if a model is appropriate, check the residuals plot. look for a pattern. If there is one, that's an argument for it not being appropriate. Okay. Next, how strong is the model? So we've gone over this. What statistic should I use? R squared. Although you could use R since this is a linear model. So we could say that it is not very strong. One could say the model is not very strong, since only 48.2% of the variability in fares is being predicted. You also see the word explained. So if they ask you about strength of model, I would use R squared. And I would also take a look at the scatter plot, because you can have a high R squared with an outlier. Our next task is to identify outliers. Outliers do not necessarily have high residuals. For example, take a look at the rightmost point. Could be considered an outlier, but its residual is near 0, meaning that we were nearly perfectly able to predict its airfare. As we know, what makes an outlier is subjective, but what's important here is that you understand the concept. So if I was doing this from a practical point of view, these are the points that I would concern myself with. They are the furthest away from this cluster here. Notice that this point has a near 0 residual, but I will still consider an outlier because it's an outlier in the horizontal sense. These points here have large errors.
But isn't that like, if you're judging it on the x-axis, isn't like, you know, like you're given, like you're setting that value? So wouldn't you consider outliers based on my values?
When you're doing regression, which is what we're doing now, outliers are not necessarily X outliers or Y outliers. It's either. So does it deviate horizontally? Does it deviate vertically? I'll consider both of those outliers. Yeah.
But isn't that X, like that one that's horizontal far, didn't we predict that? Like, isn't that kind of supposed to be based on our model?
You will find that points that are far away in X have a great deal of influence on the model. For example, you can give me a data set like this, which normally would have a regression line of this. And if you put in one point that's really far away, like here.
Wasn't that also a Y outlier?
Yeah. What happens if you take an x that's on that regression?
Well, yes, if you take an X, so if it's far away horizontally, it's not necessarily influential. But it has the most likelihood of being influential if it's far away in X. I could do maybe another situation for you. You could have a situation like that, and then stick a point like here. So normally your line would be like this, and then with that point in there, because you want to minimize the sum of the squared residuals, it's going to be like that.
But what happens if that drops all the way up there?
Like, it still follows
It-
the model.
Yeah. So that point there, I would still consider it to be an outlier, even though it does follow the trend. And you're smiling, but it matters. Because if you had an outlier like this, that matters a lot. Because it's going to make the model do that. Okay?